So I have the pleasure and the challenge to start this knowledge sharing seminar. So I wanted to give us a common understanding of what biomimetics is, because this is kind of the overarching topic. Luckily, some of you said you have no clue what this might be, so I can give you some information on this, and then I try to make a connection to our project, and I give a sneak peek of what we do in our work package and objective number 1 that we have started to do research on. Okay, so whenever I do like an introduction to biomimetics, I show this picture of how the world is basically already looking, even if we don't see all of this on the left side, and what we wish our world would look like. And I usually always quote Albert Einstein, not because it's fancy to do so, but he said, if we want to make change and to solve problems, we need a new way of thinking. Because if we have the same way of thinking that causes those problems, it's difficult or even impossible to solve problems. And in a minute, we will see that biomimetics is considered to be a problem-solving strategy. So I have the big vision and hope that what we do, whatever project it might be, that we contribute to this change of mitigation of climate, disaster, and all those topics connected to this big issue of our generation. And when I prepared these slides and I saw this picture, I was like, come on. I mean, if we have a look at our website, this is what we envision our project to lead to, kind of, which might be a manufactured ecosystem. And this pretty much looks even better than what this right side of this previous picture looked like. Well, we don't stress this topic too much, but just to draw the big picture of what our mission in our group, and I guess in this project as well, is we want to contribute to change and to make this planet recover and have well-being for all, let's say, biodiversity. I come back to this in a minute as well. So I said we have like the challenge to find a new way of approaching problems by a new way of thinking. And what we do is we consider nature itself to be a pool of ideas for solutions. And here we see the international definition of biomimetics. We have at least 10 different terms on this topic. So if you have heard about biomimicry or biologically inspired design, or what else do we have? Bionics. All those terms refer to a certain approach, which is like connecting the realm of natural systems, biology, their adaptations to certain environments, and the world of technology, of technological problems, of practical problems to solve. And this is what they all have in common and share. So we want to transfer knowledge from this world of biology into our human-centered world. I said it might be helpful, and this is what Sho also said, to have a common understanding of the field. And as the field is so diverse with all these different perspectives and approaches, I always refer to this definition. But at the end of my talk, I guess we will all agree that we don't stick to this definition alone, that we broaden the understanding in our project more towards like bio-inspiration or bio-inspired design to make it more feasible for people to connect to this project. So what we can see here is basically what we do. We cooperate in interdisciplinary, and so biomimetics is defined as the interdisciplinary cooperation of biology and technology with the goal to solve practical problems. They also include, in the meantime, like other fields of innovation. They don't yet include art or science fiction, but we do. So we put this into this this aspect of fields of innovation. And then we have like a 3-steps process in general, how we do this. So first, we identify biological systems that are of interest. We do functional analysis of those to understand what is the reason for a certain phenomenon that we observe. And then we abstract what these biological system does and try to transfer this knowledge then into application. And those biological model systems are not part of any of those solutions. So this might be a bit the difference between other fields and similar approaches where you like include plants into a solution, or you use microorganisms to produce something. So usually this is not included in the approach of biomimetics, and this is why we sometimes in this project face the difficulty to have a common understanding. We will see in a minute when we speak about Alistair Fitter's work. Okay, if you have any questions on how this definition evolved and what those other approaches are, we can speak about this later on, but this has been a discussion of decades on finding a common ground, and we're happy to have an international standard to refer to. Okay, so here are some examples because it is quite abstract to have just such a definition. We have like 8 different fields of application, fields of research where most of the research takes place. So we have architecture and design. You see on the top left a bio-inspired shading system for windows. Then we have like fluidic and aerodynamics, and you see a streamlined car called the Wanieck car by Mercedes-Benz, inspired by the boxfish. We have robotics, a huge topic, a huge field of research that is basically its own scientific discipline in the meantime. We have like communication and sensor systems. You see a tiny beetle on the right that has inspired an infrared sensory system. We have evolutionary strategies and optimization of certain compounds and construction work. We have like surfaces, one of the most prominent examples with the lotus effect that you can see on the left side, the lotus plant and the surface structure with those super hydrophobic properties. We have materials and structures in general that can be basically anything. One example is like a self-sharpening knife that you can see on the left, and we have like lightweight and construction. So these are basically the fields of research where most of biomimetic research takes place. And then we have like, I don't know, Shoshana identified more than 370 products that are on the market or have been developed at certain stages almost 10 years ago. So this is basically the number, the range of products that we know of. When we try to learn from natural systems or use knowledge about natural systems like living biological systems, we don't even have a right term to describe them, so basically plants and animals, we can learn by 2 different approaches from natural systems. The first one is the left one, like the solution-based approach. You identify a certain phenomenon in natural systems by chance or systematically. You understand what those properties of the phenomenon are, and then you abstract, like we saw with the definition, and try to implement. This is an approach that takes place quite often because people get inspired by natural systems by chance, by being out in nature or by working in the field of biology, and then they consider, okay, this could be an interesting aspect for application in technology or for a certain surface. But the more popular approach is the right one, the problem-driven approach, where we start with a technological problem issue that we try to solve, and then we systematically look into natural systems and identify those that have developed an adaptation for this problem. And then we do the same and abstract the principle and try to transfer to application and to implementation. So for instance, with those surfaces. The lotus effect is an example for solution-based approach because a biologist identified that some plant surfaces don't get dirty that easily, and he developed this effect, or he identified this effect and developed products. And the problem-driven approach can be seen in other examples. So for instance, with those self-sharpening knives, this was such a problem-driven approach when you try to find a solution so that knives can stay sharp over a long period of time. Okay, so this is basically the theory that I give to you, and now I link to and connect to our project and our vision and what I consider the most valuable aspect of this topic in connection with manufactured ecosystems. I give you on 2 slides some quotations or quotes that pretty much describe the potential of the field, because it's not only us being convinced that we do a contribution to solve problems, there are others as well. So we share all this big vision. Somebody who's often cited is Steve Jobs in a bit different context than we are usually in, but he said that one of the biggest innovations of the 21st century will take place at the intersection of biology and technology. So I guess he had more in mind what we consider to be bionics or bioeconomy topics. But he said a new era is beginning. True, I think so too. Another citation that we always quote is that biomimetics is becoming a dominant paradigm with the potential for significant scientific, social, and economic impact. And basically, this is also like the intersection where we are with our project. It's a scientific project, but it will have a social and an economic impact maybe as well. So this is what is like the vision for biomimetics. Of course, we need to be more specific. So 10 years ago, it was mentioned that it might be mostly for robotics, materials, and other fields, but this is still evolving. And another aspect based on the research about the potential of biology, I mean, we all know biodiversity is huge. So if we consider that there are 1.5 million described species, but even more that we haven't yet described in detail, in this field of bio-inspired research, researchers have just scratched the surface. And this is why there's so many possibilities for all of us, for this project, for future projects. And yeah, I'm so curious to see what those biological phenomena in the context of ecosystem services are that we identify. And also it was mentioned by a colleague of us in the US that this field might solve problems relating to health, energy efficiency, or, for instance, food security. And this is exactly where also the manufactured ecosystems topic is located. And we need the expertise of biologists, so yay for every biologist who's in the team. I'm also a biologist. I didn't introduce myself much, but I have been working in the field of biomimetics for more than 12 or 13 years now, so my biology is a bit fading, and I get this, and I become this, intermediate person. But anyways, okay, so this is what we aim for, this is what we know, and also almost 10 years ago there was an interesting quotation of also a colleague who said that there are scientific challenges that we have in the field. And I picked those up because whenever we do a project, we almost every time refer to those challenges. And also with our ecosystems, services and manufactured ecosystems topic, we are exactly in this field. So what we try to do is we have this promising paradigm of contributing to innovation and sustainability, but we need a repeatable and scalable methodology to do so. So we need to address real problems, also to develop real products in the market. We need to describe best practices, to develop a theory of biological design. And I consider this to be one of my research focuses because I always try to better understand what is the potential and how can we make it applicable in different fields of application.
Let me know.
We need tools and methods to support this process, and we need to educate.
Forget to turn off my camera.
So I basically consider that the topic of ecosystem services technologies is exactly in this field, because we address real problems. We will document like developments in the field, and the understanding of these technologies will help us contribute to the theory of biologically inspired design. We kind of develop a tool. It's more like a database or access to knowledge, and we for sure will educate society and new generations of would-be designers in the future. So here we are. This is us doing this work. I'm super proud to be part of this project and to really work interdisciplinary in this project. And I see a huge benefit of this. And I love that we all share this big vision of contributing to change. And I always say what keeps me working all day in the field is not only that I like research, it's more the people. So yeah, thank you for being part of this. Okay, now let's make a link to and a connection to the project. As we listen to Alistair Fitter next week, I wanted to make a brief connection to the theoretical aspects of the research that we do in my part of this project. So when we speak about ecosystems and ecosystem services, in this Millennial Ecosystem Assessment report, it was mentioned like ecosystems and human well-being are closely connected, and I say they are crucial. They are crucial not only for well-being, but I said for survival in the long term. And Alistair Fitter is speaking in the paper about enhancement or replacement of those ecosystem services by technologies. So this is an interesting aspect that we might speak of, and when we see the results that we already have. And it was mentioned that some of those ecosystem services are more likely to be replaceable by technologies than others. And it was mentioned that this likeliness of being replaceable is dependent on scale, complexity, and resilience of those services. And now you can see ecosystem services, like we have this table of, I guess, 26 or so. They are even, or those alone are difficult to understand. And each of those differ in scale, complexity, and resilience, which makes it even more complex. And when we bring in biomimetics and focus on the biology that leads to those ecosystem services and the technologies that might be developed based on inspiration from biology, it becomes even more complex. But this is what the project is about, and which makes it so super interesting and relevant. So I picked an example from the paper just to make it a bit more tangible. So speaking about replacement or enhancement of ecosystem services, what could this be? So just to pick one is like water quality, and a replacement technology might be what we already see, like with chemical purification that is widely used, and an enhancement technology, could be something that enhances like the passages through soil so that the performance is much better. So what we do in our objective is we want to find out which ecosystem service technologies already exist, and we want to curate an open access database of those technological proxies, but we also want to identify like which of those do not exist yet or are currently not available. So we mostly do a literature overview, but also kind of a market analysis, and then expert interviews about existing technologies will follow. And then in the end, we would like to have to present a comprehensive list of available adaptation technologies so that we can communicate this complex topic and to raise awareness about the importance of speaking about these aspects. So what do we do in this first research phase? We first wanted to identify like which ecosystem service technologies exist or are missing. The question if they are replaceable will be picked up next week with the talk with Alistair Fitter. But just to let you know what was written in the paper is like the assumption that ecosystem services cannot be replaced might have been too easily made. So there is no clear yes or no answer. It just depends on a lot of aspects, but we will listen about this or hear about this next week. So what do we do? Like first we ask which research exists in the field. We give a literature overview. There have been 2 recordings on the data that we already have, one by me, one by Alex's analysis. I highly recommend this, Alex's mostly, but mine also to give you an overview because I don't put any results in here today. And then there's this interesting topic that we sometimes speak about, but we sometimes consider that there might not be a distinction necessary, but I pick it up and give you an example of what I mean with this. So from my perspective, and the perspective of biomimetics and the contribution of biological systems to solving problems, what biomimetics is basically about is like, which ecosystem service technologies are bio-inspired or biomimetic or can be? And sometimes some of us have a different perspective on this, like Show usually then says it doesn't make sense to have like ecosystem service technologies that are not bio-inspired because, I mean, it's a contribution of biology to provide this service. However, when we do like a quick look into the literature and just look for ecosystem services and technologies, we get like 5,000 results. And if we add like biomimetic as a term, we get 16. So there's a gap in the understanding and the perspective. And as this talk today is about biomimetics in this field, I wanted to pick this up and to show you what I mean with this, or where I see the most interesting and most valuable aspect of all that we do, but of course with my perspective of a biomimetician, if you want to call me like that. So what we also do is like and here's now the example of what I mean, we try to make a link to the Sustainable Development Goals of the United Nations, and we have like here number 6, clean water, which is nicely connected to one of the ecosystem services that we deal with in the project that was also mentioned in the Fitter paper, namely water quality. And it was mentioned a few slides before that there are chemical purification technologies widely used that replace this ecosystem service. But those not necessarily need to be bio-inspired. However, or biomimetic, to be more precise. However, if we have a look at what biomimetics can do in this field, there was an interesting publication 14, 15 years ago, and they called it A Gaze into the Crystal Ball, Biomimetics in the Year 2059. And they also stressed the topic of like sustainable development goals, and they said, okay, fresh water is becoming a scarce resource. So what they then said was like, water is essential for maintaining life. So living nature excels at accessing, distributing, and managing water resources. So desalination and water collection mechanisms might be a way that we get inspiration from natural systems on how to find new technologies to provide this service. And here comes in like the real biomimetic approach of ecosystem service technologies, because what we see then in the literature is, for instance, a tiny beetle in the Namib desert, like the Namib beetle, Namib desert beetle. I only know the German term. There's research on this beetle in the desert for several years already. And there was like 4 years ago another science article saying like, could this desert beetle help humans harvest water from thin air? And yes, it can. And it can inspire technologies that can do so. And on the right of the slide, you can see how a biomimetic or bio-inspired textile looks like that can harvest water from foggy air. And on the bottom right, you can see how it looks like in reality. And this is something that we aim for with this project, to really identify which ecosystem services do we have, for which already exist technologies, where are gaps, and how could it look like in implementing those maybe solutions in the future, and to offer like, strategies from natural systems that others could pick up and develop, because we can't all of those. Okay, to sum it up, because I'm already speaking for a while, so we give insight into existing and non-existing technologies for ecosystem services. We will raise awareness for this topic, and I think future research might pick up how especially biomimetics can be part of this research field, and how it can contribute to developing such technologies. So another super important aspect is like, thank you for this extraordinary cooperation, and I can't wait for the results to be ready to share. I also have to thank my team, especially, with no picture, Emily, down here on the slide, who does all of the research and the literature, and my other people from my group. I'm always surprised how big my group already is, because it doesn't feel this big, but I mean, we are almost 10 people, so it's, there's so much to do, and I'm happy that this project contributes also to my personal research focus, which is like developing a theory of biomimetics that really makes an impact in these big problems. Not only those technical problems that it was in the past, like optimizing technical products, that's fantastic, but I would like to have this to make a bigger impact. Thank you so much for listening. I'm curious, I saw the chat is already